Hello, my friends. So welcome to my second binomial option pricing video. This will be like a series of maybe 10 or 20 short videos on the binomial option pricing model. This might be going a little bit slow because it's kind of a repeat of the last video where I showed you like a simple binomial tree model and how to price it. But I want to get more general in this video. And I think that will be very helpful when we go to like many period models in the next videos. So let's get started. So one thing in the last video, we assumed that the risk-free rate was 0, meaning that you borrow from the bank beta, and a year later you pay back beta, meaning you don't have to pay interest. But now we'll be more realistic and we'll assume that if you have a period of length h and you put beta in the bank, it becomes beta e to the rh. Or if you borrow beta, you'll owe beta e to the rh. Okay, and then let's just have a few more notation. So remember in the previous video we had the stock price, initial stock price, and then two things can happen. The stock can go up the next period to S0 times U. U is greater than 1, of course. Or it can go down to S0 times D. D is less than 1. So it can either go up or down with probability P or 1 minus P. And we want to price an option, or like more generally a derivative. So just for notation, we'll say VU is the derivative price if the stock goes up at expiry, and VD is if it goes down. So like naively, maybe we thought we could just weight the probabilities, but it turns out that absolutely is meaningless. No matter what the probabilities are, as long as they're as P is strictly greater than 0 and strictly less than 1, you'll have the same option price. So P can be 0.99 and P can be 0.5. These probabilities are irrelevant to option pricing. But in this video, we'll actually show that you can actually think of this as like you can have like a different probability measure where you can think of this as like an expected value. It'll be like it'll be called the risk neutral measure, and it'll be with that probability, the risk neutral probability, let's call it P star, times the option payoff plus 1 minus P star times the option payoff if it goes down, discounted back. That will be your value. The reason the P doesn't matter is because in the last video we showed that in the very simple one-step binomial tree model we have a complete market, meaning we can actually replicate the payoff of our option or derivatives contract with a simple portfolio where we're long delta shares and we borrow beta from the bank. So to be a little bit more precise, we're interested in the value of the option or the derivative at time 0. So we construct a portfolio, and I call the portfolio time 0 pi 0, and the portfolio is going to be delta shares of the stock, and we're going to borrow beta from the bank. Okay, so if the stock goes up, our portfolio is now worth delta S0 times U minus beta e to the RH, because now we owe the bank more money. And if the stock goes down, it's going to be delta SOD minus beta e to the RH, right? So we showed basically in the last video how, so you have these two equations, this VU equals delta S0U minus beta e to the RH, and VD equals delta S0 D minus beta RH, and we can solve for delta and beta, meaning how much of the stock and how much we should borrow for the bank, and you get these values here, and this is like a general expression. So then the value of derivative at time t equals 0 is that portfolio with these weights of delta shares and borrowing beta from the bank. I guess this should be a minus beta. Sorry about that. But anyways, you can do some messy algebra, and you can actually write, this should be a minus sign, sorry guys. So you can do some messy algebra and waste paper, or maybe I'll show you a Python package that will do the algebra for you. And you can actually write this option price as e to the negative rh p star vu plus 1 minus p star vd. And this p star has this expression e to the rh minus d over u minus d. And this is known as the risk-neutral probability. It'll come back later in many things with complete markets. So basically, it kind of means you can price the derivative as the discounted. You discount it to times 0. That's the e to the negative rh. Expected value of the payoff, but not under the real probability p, but under the risk-neutral probability p star. So this will be very helpful when we're extending to multiple steps. This p star has to be between 0 and 1, and the condition is this condition, which makes perfect sense because if this was not true, if let's say e to the rh was greater than u, why on earth would you buy a stock? You could just invest in the bank and you make a better return with no risk. Or if it's e to the rh is less than d, like why on earth would you invest in the risk-free rate where basically you're gonna that's like negative interest rates, right? Where no matter what you'll get more money with the risky assets. So this is like an arbitrage condition too. But basically, this is very useful and for us to extend this to multi-period, and we'll do that tomorrow. Thank you guys.